Everyone, and welcome to Open Source Days. It's good to have you all with us. I'm Michael Dolan. I'm a senior pipeline developer at Epic Games, and I'm the chairperson for OpenColorIO TSC. And I'm going to get us started here. So the title of our talk is OpenColorIO, Consistent Color Management for VFX and Animation Pipelines. And just to give you a brief overview of what we're going to be covering, I'm going to be giving a introduction and a brief project update on what we've been up to over the last year. And then Doug Walker and Patrick HODOUL are going to talk about OpenColorIO V2, which they've been working on at Autodesk for the last about 3 years. And then Carol Payne of Netflix is going to be talking about the new OpenColorIO documentation and website to accompany the V2 work. And then Carol will moderate our Q&A. So if you have questions, feel free to post them in the Q&A right here in Zoom, and we'll make sure to have some time at the end so that we can answer those. And if you have any questions following the session, feel free to ask them in either the ASWF Slack or the OpenColorIO Slack, and we'd be happy to answer questions there as well. So just to give you a brief introduction to OpenColorIO, if you're not familiar, OpenColorIO, also known as OCIO, is an open source library for visual effects color management that provides 4 main capabilities. So first, there's a config file for documenting a color pipeline that is used either for a specific show or even across an entire facility. OCIO also provides a loose set of user interface conventions, for accessing color management from within digital content creation applications. So that's the user-facing side. Also, the ability to read many of the lookup table or LUT file formats that are used across the industry, which makes OCIO very flexible and able to fit into a lot of existing pipelines. And then lastly, pixel conversion engines for both CPU and GPU. OCIO was introduced about 10 years ago by Sony Pictures ImageWorks and has become an industry standard for implementing color management in visual effects and animation. It's already integrated into dozens of apps, many of which you probably use or are familiar with, and it's being added to new applications regularly. Hundreds of films have used OCIO. Pretty much every major motion picture with visual effects over the last quite a few years has used OCIO for most shots. So it's very commonly used. So just as a general update, kind of talking about where we've been at for the last year since Open Source Day last year at SIGGRAPH. So following last year's event, the Academy Software Foundation TAC and Governing Board voted to graduate OCIO to an adopted project in the ASWF. So we were the second adopted project in the foundation. Since then, we've had 182 commits by 25 contributors and 44 issues closed. So very healthy amount of contributions and activity. There's a lot going on the project. It's a great time to get involved if you're interested in participating. It's all done in the open, and we're eager to have help, anyone who's interested. So we've also spun up 2 project working groups this past year. One to look at revamping the OCIO documentation and website in preparation for the V2 release. That's being led by Carol Payne of Netflix and Sean Cooper of DNEG. We've also recently spun up an ACES config working group, which I'll talk more about shortly. Last week, we had a talk and a paper at DigiPro. If you weren't able to attend DigiPro, those will both be posted to the OCIO website in the near future, so be sure to check that out. The paper in particular covers a lot of detail around the V2 feature set, which is very helpful. We've had some new members to our technical steering committee this past year. Mei Chu of Sony Pictures ImageWorks is now joined, and Carol Payne is joined to represent Netflix, and Mark Titchener from Foundry. So we're continuing to expand and to try to lead the project well. We've had some updates to build and CI over the last year. Last year at Open Source Day, we talked a lot about our CI and build efforts, which had been a part of our incubation phase of our time in the Academy Software Foundation. This past year, the entire foundation decided to move CI infrastructure from Azure pipelines over to GitHub Actions to be more tightly integrated with our repositories, which has been it's been a great move, and it's been added a lot of nice capability for just managing our projects. We've also expanded our CI jobs somewhat. We're now regularly testing on both VFX Reference Platform 2019 and 2020 images, which are both provided by the ASWF Docker project. If you're not familiar with that, they're Docker images that provide various VFX Reference Platform content years, and it's great for both CI and for just building projects on your own too. So be sure to check that out. We're also doing nightly CI now, so we do a latest upstream dependency build. So basically, we have a number of upstream dependencies that we pull from other repositories, and this allows us to pull the latest tag for each of those, just to see how changes coming downstream will affect us in the future, so we can maintain stability with new releases. And we also run static analysis builds with Sonar Cloud each evening, and that includes test coverage analysis and other things to help us keep the code quality high. We've also been working with the ASWF CI working group this past year as we implement GPU CI, which is really important for OCIO since the GPU rendering is widely used. So we're running this on GPU instances on AWS, and we're currently in progress setting this up, but we're hoping to have it up and running within the next month or two. So last year, we completely rewrote the Python bindings for OCIO with PyBind 11. So now we fully support Python 2 and 3. And one of the great things with PyBind is NumPy array interoperability. So any of the API for OCIO that can operate on pixel arrays or numbers can be passed NumPy arrays directly and can also return them. We've also worked on some revisions to PyOpenColorIO to be more Pythonic. One of those is implementing a lot of Python iterators, where previously it was more of like a C-style iteration where you're iterating based on a count of some object. So it's just a little more easier to pick up for Python developers. We've also expanded the previous case of having constructors for each class that allows you to define the attributes in the constructor. And so all of our classes support that across the library wherever it's possible to just ease config authoring. And now the context class and some of the other metadata interfaces throughout the library can behave like Python dictionaries, just to be, again, more familiar for Python developers. We're still working on our test suite, which Meichu has been leading that development, and we'll plan to be done with that before the V2 release. So I mentioned before that we have a new ACES config working group. The ACES config in the past has been very widely used, and it's been an awesome tool for studios that either don't have a color scientist or want to have a really good starting point for an ACES pipeline. So we're looking at that, and we really want to create a new ACES config that takes advantage of the OpenColorIO V2 features, which Doug and Patrick will talk a lot about. But there's some really key benefits to that. And so we've actually started a new repository, which is called OpenColorIO configs ACES, I think, where that project will be started up, which is under the Academy Software Foundation GitHub organization. There's not much there yet, but we're working on it. And the key thing is that this project is going to be done in 2 phases. So phase 1 will be to create an ACES reference config. This is a config that encompasses just the ACES transforms and not necessarily trying to account for all the typical color transforms that you would need across a studio. And the goal here is to have a OCIO ACES reference implementation so that, and we could use that to apply for the ACES logo program to be officially supported. And one of our main goals is to be LUT free. OpenColorIO V2 introduces a lot of built-in transforms providing the underlying ACES algorithms for higher precision and performance. And so our goal is to make this config be mostly standalone, and also to generate a lot of the config structure with a library that Thomas Mensenkohl created that essentially walks the ACES repository, collects all the transforms, and then can build the config structure from that. And this will allow us to use continuous integration and other tools to make sure that we're always staying up to date with the ACES repository and catching differences. Phase 2 of this work would then be to create a superset of that ACES config, which adds in a lot of the functional and useful color spaces and transforms that are needed to just run a studio color pipeline. And so we want to utilize OCIO V2 features as much as possible in this config also. But these two configs will be available either to use directly or just as a reference or starting point for your studio's config. And we hope that it can be really helpful and also provide a really great example of how to utilize the new functionality. If you're interested in being involved in that, the working group meetings are hosted every other Tuesday currently. In the OCIO dev calendar, you can see those meetings, and we'd love to have your input. Also, we rebranded OCIO recently with a new logo and branding kit by Mario Rikiki from DNEG. He graciously designed an awesome new logo and lots of new visuals for us to help just continue to have branding consistency, and we're really thankful for his contribution there. And with that, I'm going to hand it over to Doug Walker to talk about OpenColorIO V2.
Thanks, Michael. Yeah, I love the new branding kit that Mario put together, and I can't wait to incorporate more of that into our website and things over the coming weeks. It looks really amazing. So I'm Doug Walker. I'm technology lead for color science at Autodesk, and I'm also serving as the chief architect on the technical steering committee for OpenColorIO. So it's been an interesting 3 years. Just to kind of recap some of the history for the OpenColorIO V2 project. So this began at SIGGRAPH 3 years ago with a proposal that we made that was well received, and based on that, we were able to spin up a V2 working group consisting of members from most of the major companies in VFX and entertainment, and Autodesk was able to support Patrick, Bernard Lefebvre, and myself to work full-time on this project. So there were a number of, it's been 10 years since the first OpenColorIO release, and a lot has changed in that time. These 4 trends in particular influenced the V2 feature set. So firstly, the increasing importance of GPUs, including for rendering final frames. Also the fact that ACES has had a tremendous influence on VFX workflows and the way color is handled. Also, color management has become more complex as the industry wrestles with lots of different proprietary color spaces and the arrival of HDR television and so forth. And finally, that OpenColorIO is also being used in industries adjacent to visual effects. We had a couple of high-level design goals for the project. First is that existing config files should continue to work. And second, that it should be simple to update existing apps to the new API. And we feel that we've met both of those goals. So I'm going to give you a quick overview of new features. We don't have time to cover them all, but you could go to our website to see a more complete list of the new features. And also we wrote an extensive paper for DigiPro that goes into some of the background behind the new features. So we encourage you to check that out as well. So ACES, a lot of the new features are related to ACES, and a lot of the people that work on OpenColorIO are also involved in the ACES project. The way I think of it is ACES is sort of the what of, what should the color transforms be? What is the color science? What is the color pipeline that should be used? And OCIO is sort of like the how. It's, okay, we have this set of color transforms we want to apply. How should we apply them in VFX software? And so a number of our new features are ACES related. Many of the people in VFX who encounter ACES or use ACES do so through the excellent OCIO config for ACES, which was created by HP Dweeker and updated for ACES 1.1 and 1.2 by Thomas Mansencal. And that has been hugely successful. There are some edge cases where we've identified problems, and those are related to the limitations inherent in 3D LUTs. And so for OCIO V2, we've made it possible to implement the ACES config without relying on 3D LUTs, and that allows the transforms to remain faithful over, a huge exposure range. Another ACES-related feature is the Academy Common LUT format. So this is something that was a big part of the recent ACES 1.2 release. It's similar to OpenColorIO in that it allows you to construct a pipeline of basic sort of operators or building blocks that are things like 1D LUTs, 3D LUTs, matrices, ASC CDL, etc. It's very well documented. There's a thorough set of unit tests in OpenColorIO, and there's actually a common LUT format implementation working group that meets every other Tuesday as part of the ACES virtual working groups, and we encourage you to get involved with that if you're interested in CLF. But we have full read and write support now in OpenColorIO, which is great, and which I think will help adoption. A number of the other new features are around improving the user experience. So, the ACES config, for example, has over 300 color spaces, and so that can lead to some pretty overwhelming menus. And so we've added new features to be able to group color spaces by category, to use hierarchical menus, to hide color spaces if you want to keep them in the config but not have them in the menus. We've also added some new rules. So there's a file rule system that brings more power to how you assign good default color spaces based on the file path or extension. There's viewing rules which help applications decide which views are most appropriate for a given color space. And finally, we've got a lot of application best practice code to kind of illustrate how the new features work and to provide examples for application developers. One of the big color science related features is display color spaces. So in OCIO V1, there was basically one color space that did the entire transformation from scene linear reference space to the display space. In OCIO V2, it's possible to break that down into a combination of a view transform to a display reference space and then a display color space. And this makes it brings OCIO in line with a lot of other color science initiatives such as ACES, such as the HDR television standards. And it also facilitates other benefits like the ability to convert from one display color space to another without having to invert a view transform. Related to displays, so as you know, a lot of the sort of de facto standard for monitor profiles in color management is based on ICC profiles. So on Mac and on Windows, you can ask the operating system for a profile that describes the monitor. As more and more monitors are wide gamut monitors, the assumption that everything is sRGB becomes kind of less and less relevant. And so now there is essentially a bridge between ICC and OpenColorIO. So for config authors that want to, they can provide a way to link to an ICC profile, and for applications that want to, they can use OCIO to emulate what would be seen in an ICC-based application. So with that, I'm going to turn it over to my colleague Patrick HODOUL to talk about the new GPU renderer.
Thanks, Doug. Now I have few slides to present you some very important feature for OCIO V2, more related to software parts, but which are also critical improvements. So for OCIO provides a flexible processing model that consists of a pipeline of mathematical operators. In OCIO V1, the CPU rendering engine evaluated the chain of operators precisely but the GPU rendering engine converted the operator pipeline into an approximate one. For technical details, mainly it was the GPU pipeline was replacing all the LUT by one single 3D LUT with all the corresponding approximations. In OCIO V2, the GPU renderer has been completely replaced with one that implements all the operators and is able to process pixels as the CPU does. The image shows the result of testing done at Sony Picture Imageworks. The result on the lower right shows an amplified difference image between the CPU result and the OCIO V1 GPU result, which indicates significant errors. The result on the upper right shows the same comparison using the OCIO V2 GPU renderer, with the black image indicating a precise match to the CPU. What is now important to mention, the GPU public API changed a lot since OCIO now needs to upload any number of textures. In your color transformation, you can have any number of LUTs, and all these LUTs are now converted to 1D, 2D, or 3D textures. However, it allows much more customizations, and the helper class provides an easy OpenGL integration. These two aspects are really important to any GPU integration in any kind of apps, because there are always specific needs or limitations. So you need to be able to fully customize the information you received. But at the same time, some integration are using directly OpenGL. So we provide helper class to have a very seamless integration for that kind of applications. And one example is the known OCIO display command line tools, which is using this helper class. Processing improvement. So many of our processing improvements are also being made. Due to a number of optimizations, such as additional use of SSE vector instructions, CPU pixel conversions are now up to 20 times faster. Just to highlight that the SSE integration was already done in OCIO V1, but we really enhance the support for all existing ops and new ops. So now all ops have an SSE support. And if your processor does not support SSE, then it's automatically disabled. OCIO now supports integer pixel buffers in addition to floating point. In many cases, source image file formats are integer-based, and the new capability brings performance improvements. For example, applications no longer need to pre-convert buffer to floating points. This is a huge improvement. Improved transform pipeline optimization also contributes to the performance improvement. For example, OCIO is now able to generate an equivalent forward LUT for an inverse LUT, including 3D LUTs. The various optimizations are also now controllable by the public API or via an environment variable. This latter point is extremely important if you want to debug something. You can completely disable optimizations. A new cache system has been introduced for OCIO processor instances. In fact, the pull request will be in a few days, but it's really close. This should facilitate improved performance in applications that need to play back a timeline of clips that each require different color processing due to context variables. Special attention, not yet. Special attention was given to preventing context variable from invalidating the cache unless they directly affect the result. Yes, command line tools. Thank you, Michael. OCIO has always had a very useful collection of command line tools, and V2 provide interesting new capabilities. I will not list all command line tools, but just highlight some of them. OCIO checkLUT also allows sending a numeric RGB value through a LUT file, which is often useful to troubleshoot problems. It also checks the LUT syntax for errors. OCIO write will build an OCIO processor from arguments such as source and destination color space, and then serialize the resulting operators in an XML file in either CLF or CTF format. This allows one to see the exact operators OCIO is using to perform a specific color space conversion, and is very useful when troubleshooting. One I have added is OCIO display. Can now, it's a V1 command line tool, but we improve it to print the fragment shader program and select the optimization level, also with the perspective to debug something. OCIO Make CLF will convert any of the LUT formats that OCIO supports into an Academy ACES command LUT file format. And in addition, is able to prepend and postpend the necessary color space conversions from and to ACES 2065-1 to the color space expected by the LUT in order to build an ACES compliant LUT modification transform. OCIO Convert, which is a tool from V1 that is used to process images through OCIO, now is able to process using GPU. And finally, OCIO Perf, a new command line tool for V2, allows one to benchmark processing speed on a given system and through a given color space conversion. I heavily use that last tool to check all the performance improvement we did. Next slide, thank you. Many improvements have been made to improve the robustness of OpenColorIO. So Michael mentioned some of them, but just to recap for everyone. First of all, we have increased the number of unit tests by more than tenfold, with more than 1,000 total tests. And we continue to add some. This is really important to guarantee the quality of the library. In addition, we have now GPU unit tests in addition to the CPU and Python ones. This allows the GPU results to be compared against the CPU results. This also is completely new with V2. We developed a GPU framework dedicated to unit tests. So we can, for any ops, we can compare CPU and GPU. And we also have a Python framework to test the Python API. Furthermore, a sophisticated continuous integration system is now in place to validate all pull requests on GitHub. So Michael explained a lot this new aspect, but just to highlight that this system tests 10 Linux build configurations, 5 Mac configurations, and 5 Windows configurations, as well as support static analysis and checking for DCO sign-off and contributor license agreement. The two later points are extremely important for open source development. It's just a second. Just to highlight what improved robustness means. It means that you can rely on branches on the GitHub repo to be correct, because we have way to enforce the quality of any merge code or changes, unit tests, and so on. So this is really a major improvement for everyone. So now I will let Doug present you OCIO V2 timeline.
Thank you, Patrick. So it's been a busy 3 years for us. We were at Open Source Day last SIGGRAPH saying that showing roadmaps, showing that we would be feature complete at this SIGGRAPH. And I'm very happy to report that we are in fact feature complete. And so OpenColorIO V2 is now ready to test. here's the timeline. So we're showing 3 years of feature development from 2017 to 2020. We're now feature complete, which means the feature development work is now done. There's a couple of pull requests that are still landing last week and next week, but for all intents and purposes, it's V2 is now ready to test. And so the next 4 months is dedicated to bug fixing, stabilization, refinement of features based on feedback from developers and people testing. And then we will make an official stable V2 release at the end of this year. And OpenColorIO V2 is part of the VFX reference platform for calendar year 2021. So we hope that you will start seeing V2 in the applications you know and love starting next year. So we'd like people to get involved. This is a great time to get involved with the project. We could really use your input and your help. Code is available in the master branch on GitHub. As Michael mentioned, we have a new website and documentation. And it discusses some of the new, well, it discusses all of the new V2 features. It's a work in progress, but there's information there to get you started. We'd like even if you're not a software developer, we'd like your help testing, writing tutorials. You can look at the coordinates here to figure out how to get involved using either the OpenColorIO forums on ASWF or our Slack instance, which is very active. And finally, I'd like to, next slide, thank you. So this has been a big effort, the development of V2. It's involved contributions from both individuals and groups. So in terms of the individuals who have contributed, Michael has done a huge amount of work on not only the awesome new Python bindings, but the CI infrastructure and led the CII best practices and many other things. Mei Chu has been helping with the Python binding testing. Carol Payne and Sean Cooper have been leading the new website homepage and new documentation infrastructure. We have many people, Mario has done an amazing job with the new branding package. We've got many people who are contributing to OCIO for the first time over the past year. So people like Rashil Gandhi, Chin-Ying Lee, Simran Rusher-Cipher, many people are getting involved, and I think that's a really great sign indicative of the health of the project. I'd like to thank two groups in particular. So first, the OCIO V2 working group. You know, we really appreciate the time that you guys spent in many meetings talking about the new features and sharing your insight into how OpenColorIO is used. It's been an invaluable resource for Patrick and Bernard and I to draw on. And we thank you very much for that. And finally, I'd like to thank the Maya and Flame teams for supporting us, for Patrick and Bernard and I. So you didn't get to meet Bernard Lefebvre today, but he's been an amazing contributor over the past 3 years with Patrick and I. And we really want to thank the Maya and Flame teams for making this possible and for having the vision to recognize the importance of this open source infrastructure that we all rely on, not only OpenColorIO, but other projects like USD and Material X, many of the other ASWF projects, for having the vision to support that and to invest in keeping this these projects robust, vibrant, and healthy. So with that, We hope you will enjoy V2 and find a lot of cool things in it. And I'd like to turn it over to Carol Payne from Netflix to talk about the new documentation and website.
Thanks, Doug. Hi, everybody. My name is Carol Payne, and I work for Netflix as an imaging specialist on our creative technologies team. And we all recognize the amazing amounts of work that have gone into OpenColorIO V2 over the last 3 years. It's really been incredible to see everything that's happened. And with that comes, a lot of changes, and we realize that in order for our users of all kinds to be able to make the most use of the new features, the OCIO V2, that we needed a documentation update. And we needed to be able to, put into writing all of the amazing work that's been done so that users could easily pick it up and get going without a lot of headache, and have all that information at their fingertips. So we did a couple things, the first of which is a new landing page, a little bit of a modern update with some nice new colors, hopefully to make the information quick and clearly available for what's where and when. We started thinking about how to approach the new documentation and came up with a system that we feel that OCIO users really fall into 3 main categories. Obviously, there's some overlap and things like that. If you go back 1 slide, sorry, Michael, I'm going to talk a little bit. But we really feel like they fall into a couple main categories. Artists that are using it from a surface level application side, studios that are integrating it into their pipelines, so pipeline TDs and config authors, and then developers who are integrating it into software applications that we've talked a lot about, like Maya and Flame and all of the other amazing applications that support OpenColorIO. So that's where we started, and we realized we needed a pretty big revamp of our entire documentation set. So to that end, we have moved to read the docs, and we want to go to the next slide. Thanks, Michael. So our base level documentation is now read the docs via RST and Sphinx. Our API docs are built from the C++ headers and using Doxygen and Breathe, and also generating that RST for Sphinx. And so it all lives under one place now. The main part, a lot of the main parts of the documentation are handwritten by us, and then the API docs are auto-generated. So that's sort of the general philosophy that we took approaching this project. Is pretty similar to a lot of other documentation projects out there, nothing too crazy or out in the wild, but it has taken a amount of work to move the infrastructure and get it up and going. We'd love for everybody to get involved and check it out. So it's still definitely a work in progress. So as you navigate the new documentation, please, take note of what you find. There's still a couple things that are highlighted there that, are still from V1 or are, works in progress. We know that we need a decent amount of work in documenting the Python API with examples and things like that for people to easily pick up. So we're going to be working on all of that. But yeah, so if you want to go to the next slide, just please get involved. It's still a work in progress. If you have issues that you feel need addressed, feel free to log them on GitHub or talk to us on our Docs Slack channel. Any of us will get back to you there and take appropriate action. It's also a great place for you to get involved and ask questions about our new documentation or about OCIO V2 in general. If things aren't clear, if we're missing something, any feedback we will welcome at this point in time to really make the upgrade experience to V2 smooth, but also taking a real look at just overall how to get a new user onboarded to using OCIO in whatever capacity is needed, whether you're an artist, config author, or a software developer. And I think that that is all I have to say about that. Thanks for being here, guys. We have a couple questions, so we're going to move directly into the Q&A section of the talk. So please continue to put your questions in the Q&A box, and we'll kind of go down the line and answer them with, you know, the questions with the most upvotes and sort of in the order that they were received. So we're going to start with a question from Rod Bogart. Can the 3D LUT inversion occur on the GPU?
I'll take that one. Yeah, thanks for the question, Rod. The way that works is the 3D LUT is converted into an equivalent forward 3D LUT using the CPU, and then that's uploaded to the GPU, and the GPU does a forward 3D LUT evaluation. We found that that works quite well, but we're interested in getting people's feedback from that. Another thing that we should mention related to 3D LUTs is that the GPU now allows both tetrahedral and trilinear interpolations. So that's another sort of improvement from V1 because tetrahedral interpolation was not supported on the GPU.
Great, awesome. The next one from Stephen Shapiro is, which major softwares or DCC vendors have already been testing OCIO V2?
Well, certainly at Autodesk, a number of our product teams have been testing it. I'm not sure if there's any other people here who can speak to other DCC vendors. I know some of the studios have also been looking at it for some of their internal tools.
And we've gotten some feedback that you know, foundries began investigating testing on their end as well through the TSC, and so it's starting to pick up. But yeah, there's been, you know, some ongoing studio testing probably for a year. Interestingly, and related to the 3D LUT, one area that's been tested in production a bit is you can actually build OCIO V2, use it to invert a 3D LUT, and then write that out to a LUT file, and then use that in OCIO V1. And so that's been used a decent amount in production and has been a pretty effective way to kind of see how that performs.
And Silhouette, Paul just mentioned in the chat that Silhouette from Boris Effects has been looking at the new version as well.
Yeah, that's great. Now that we're, you know, feature complete, to wrap up that question, now is the time that we would really like to get in touch with all the major applications and new applications that are interested in integrating OCIO and work with you over the next few months to make sure that everything is working as intended. We anticipate catching some bugs and fixes, and we need everybody's help to do that. So the more that you can get in there and start to test things, the better. And let's see, next from Nick Shaw. When are there likely to be pre-built binaries or a simple installer so non-developers can install OCIO V2 to test it?
So as we you know, get closer to a V2 release, one of our initiatives will be to try to target, you know, a lot of package managers and from various platforms, as well as hopefully also Python package index for the bindings to ease that. There's an initiative in the CI working group right now. Well, one of the goals is to look at utilizing CI build artifacts to be able to distribute some of those, you know, and as sort of a continuous deployment setup. And so I think that will definitely be a goal. I'll also mention that from the perspective of building the library, we've introduced a new CMake variable or argument that's OCIO build ext packages. If you set this to all and run a build, all the external dependencies can be pulled from upstream repos for you automatically to ease building. It still requires building, but it's there for people that don't necessarily want to have to chase down all the dependencies.
Great. The next question is the new studio config expected to be LUT free as well as the reference config?
I think that's a goal, but it remains to be seen whether that'll be possible. It's possible certainly that there will be some transforms that aren't supported yet in built-in transforms, but it's also something. It's an interesting case for finding new cases for new built-in transforms that the main OCIO library could support.
Same. Thanks, Rick, for the other question. Are the GPU and CPU paths bitwise identical?
Well, when you're doing floating point calculations, it's hard to get bitwise matches. So they're not going to be bitwise matches. Even if you did on 2 different GPUs, they wouldn't be bitwise matches. So that's not really feasible, but they're extremely, extremely close. And there are now unit tests in place that actually compare the CPU and GPU results and make sure they're within a certain threshold.
Great. Are there any plans from Jean-Francois? Are there any plans to target other GFX APIs as well as OpenGL? So CUDA, Vulkan, Metal.
We've had some interest of people to contribute additional bindings along that line, and if people have interest, we'd love to work with you and get your contributions in that area.
It looks like Dennis wrote in there that they're looking at contributing OpenCL support, so already have a little bit of an answer there.
And just Carl, sorry, just to answer also that we try to build the API easy to integrate CUDA, Vulkan, and Metal. We put extra attention to ease your work. So you have an example with OpenGL, but we really decoupled the collect of information from the OpenGL implementation.
Let's see. If a DCC tool already implements the OpenColorIO library, will it be very difficult to update to the newer version?
One of our goals was to make that as simple as possible. So we hope the answer is no. It's certainly, we're interested for your feedback on that. The only area of the API that really changed dramatically was the GPU API. And as Patrick said, that was kind of unavoidable given that we need to now allow updating, uploading more than one texture onto the GPU and so forth. But we think it should be straightforward.
And for the GPU integration, you now have examples, so it should help. Even if it's completely different, you have command line tools. We have a static. We have helper classes, so it should give you hints how to do it or to reuse them as is.
There's kind of two aspects to upgrading. So the first aspect is just getting the app up and running, basically with none of the new features, just taking advantage of the improved processing precision and so forth. That we think should be straightforward, but there still is work involved to implement the new features, and we want to emphasize the importance of that because a lot of the benefits, like the user experience improvements and so forth, do rely on applications revisiting their OCIO code and implementing support for those new features.
So, we have a question from Satish Goda about support for web browser-based workflows.
Yeah, that's a good question. It came up also during the DigiPro presentation, and we haven't really looked at that. But I agree, it would be very interesting. And if someone has a use case for that, it'd be great to get you involved in the project. I will point out that the support for ICC profiles is perhaps the best way to emulate what some of the browsers are doing in terms of their color management, or tying into that.
Awesome.
Noticing that we also have a question in the chat from Rick Sayer, sort of following up on the LUT inversion. And Rick is asking whether, he said it would be great to allow a special ground truth mode which skips the, quote, make a forward LUT to represent the inverse, unquote, applying the full inversion operation per pixel. And that is possible. So it's only available on the CPU because the nature of the calculation would be very, in other words, searching through the forward LUT to find the inverse is very difficult to do in a shader language. But it is available for CPU evaluations, and there is an optimization setting that allows you to switch between the exact evaluation or the fast evaluation. And Rick was also asking, is it possible to control the size of the intermediate LUT? That is currently a fixed size, but that would be a simple pull request for someone to allow that to be configurable.
Awesome. I have a question from Alex Freestone. This is one I think we also got at DigiPro, but what can we see in the future for version 3 of OCIO? Forward thinkers.
Good question. Yeah, I mean, at DigiPro, I was saying that we've been so immersed in getting V2 out the door that it's been hard to think about anything else. So I would say, ask us next time. I don't know if other people have suggestions, what they would like to see for V3, but we're in the thick.
I would say it. Yeah, if you have suggestions, please get involved. But yeah, we've still got the road to being done and released with OCIO V2 is still ahead of us, and so it's really working on getting solid and wrapped up and very stable is the future for now. And Zach Lewis wants to know if the DW in Hue Correct DW3 stands for Doug Walker.
That may be. That was one of the ACES algorithms that is now implemented in OCIO as well. Thank you, Zach, for for your investigation of the source code. We appreciate it.
Yeah, that's great. Zach also wants to know about CTF.
CTF is an interesting new feature. So we were talking in the presentation about the common LUT format, which is part of the ACES 1.2 release. And so we fully support the common LUT format that has a lot of nice operators like logarithms and things that make it possible to build LUTs for scene linear color spaces. But it does not support all of the OCIO features. So there's an extension to CLF, which is called CTF. It looks very similar. It's an XML file format that's very similar to CLF, but it allows all OpenColorIO features to be serialized into this XML. And so that's quite useful for a number of workflows where you may need to serialize a given OCIO processor and send that to someone. Patrick mentioned that there's an OCIO write command line tool that allows you to do this basically. So you give it like the config, the source and destination color space, and it will write out an XML file that gives you the exact implementation of that processor.
An interesting.
Go ahead, Patrick. I know we're almost
An
out of time.
interesting side effect is that you can output a CLF or CTF and dig inside the color transformation to understand each step. So for debugging purpose or just learning, it could be very interesting also. It's only a side effect, but it's an ASCII file, so you can read it.
It's great. I think that we've gotten through a bunch of questions. We have about 5 minutes left. Any of you guys have anything else that you'd like to touch on?
Just
awesome. Yeah, go ahead, Doug.
That we're really encouraged to see how energized the community is. We want to keep it going. We want to get people involved, and so we encourage you to check out the new website and post your thoughts, questions on the OpenColorIO forums or on our Slack channel, which is very active.
Yeah. Thank you, everyone, for the questions and the contributions. And Carol, thanks for moderating our Q&A.
Yes.
No problem. Thanks, everybody.
See y'all in Slack.